Question 7. Complete the mechanism for the following reaction. So for question 7, I've got 2NO plus O2, and that gives 2NO2. Now I've got 2NO here, so if I have NO plus, and I'm getting N2O plus, so that means I've got another NO because I've got 2. So I will have NO here. To be able to get the 2N here, I've got two N's here. And that will give me oxygen here. So I need a half of oxygen gas. So that will be balanced because I've got 2 nitrogens here, 2 nitrogen there, 1 oxygen there, and 1 oxygen atom here because it's a half of O2. That's 1 oxygen. So that's 2. So that's it. That's balanced. For the second one, I have got N2O, which is coming from that one, right? Plus, which is then giving me again 2NO2, which is giving me that back. And I've got the 2N here. I've got the 2N here. So I only need oxygen, so that has to be O2, but I've got 4 here. I've got 4 here. I only need 3 more, so that'll be 3/2. And that's balanced. Because I've got 4 here for oxygen, 2 times 2, 4. And I've already got 1 here. I only need 3 more, so I'll do 3/2. And that's done. So that's question 7. Question 8. We're going to distinguish between a first and second order reaction. A concentration versus time graph is plotted, and the first order reaction has a constant half-life. For a first order reaction, the rate constant can be expressed as K. So we know what K is. So this is question 8. We know what K is. K equals ln 2 over T half-life. Okay. But the question says, if the half-life of a reaction is 30 seconds and the initial concentration, so C naught initial, is equal to 0.128, right, mole per decimeter cube. What is the concentration after 60 seconds? But the half-life is 30. So what we're saying is every time it goes to half of this, so we're going to get C over 2, and that will be half of that. And the half of that is going to be, so if you get your calculator, and you can go right, turn it on, and so you want 0.128 divided by 2. So that's the half of the initial value. Standard to decimal, that will be 0.064. If that's the case, so what do we need? So that's the 30. So that's 30 seconds. That's half-life. Then if I then go to half of that, so that'll be C0 over 4, because I'm not divided by 2, and that will be 0.032, because I'm dividing 64 by 2, 32, the other half there again is 30 seconds. The next half-life will be, right, C0 over 8. And that'll be 0.016. That's the other half-life. So that's another 30 seconds. And so we could basically carry on from there. The next half-life will be C0 over 16. So we divide that by 2. That will be 0.08. Is that 0.8? Because we got 0.016 divided by 2. So just 0.008. That's it. That's what I meant. There you go. Does that make sense? 1, 2, 3. So that's good. That's 0.08. Right. And that's the other half-life. So that's 30 seconds. So you can see that's 30 there, that's 60. So 60 seconds you get 0.032. So that is for 60 seconds. And this is for 90 seconds. And this is for 120 seconds. If we go again, C 0 over 2 again, so that'll be 32. And so now I've got 0.132 divided by 32. Right, so we get, so we're dividing it by 2, so we get 0.004, and that's another 30 seconds, and that's 150 seconds. Okay. So the answer to the questions here, when it's 60 seconds, it's 60 seconds is 0.02 moles per decimeter cube. And when it's 120 seconds, is 0.08 mole per decimeter cube. And when it's 150 seconds, it's 0.004 mole per decimeter cube. So those are the answers we're looking for. And that's question A, B, and C. And question D is basically asking us to calculate K, which we can do using that formula there. So K is basically ln 2 divided by 30, because half-life is constant, 30, 30, 30. So that's 30 seconds as well. And if I bring the calculator back, and so what I need to do is just say, right, fraction key there, and ln, and 2, close bracket, arrow key down, and I want 30. So that's the answer to that one, equals 0.0 231. And that's the value of k. So that's the value of, so that would have been, just do, if you do 0.128 divided by 4, you should get that. Let's check it, because I didn't think I'd do it that way. So if I clear that one, 0.128 divided by 4, yeah, we got 0.8. And this one is 0.128 divided by 16. Yeah, that's correct. And the final one is 0.128 divided by 32. Exactly, so that's good. That's 1, 2, 3. Okay, that's good. Excellent. So those are the answers we're looking for.